Alright folks, so we are about to start chapter 11. I actually think that this is one of the more important chapters just because it's all about common sense really. It's a chapter where you have to start being able to think, analyze, look at stats, draw conclusions, make inferences, all of that stuff. This is stuff that you use forever. Big businesses, this is stuff that you use on a job, whatever. This is stuff where you're going to be analyzing data. And that's super important. So this is chapter 11. Ooh, that's a good color. So this is chapter 11. It's section 11.1. This is called normal distribution. So this has the ability to be kind of a tricky section because there's a little bit of stuff going on with it. If you've ever heard anyone talk about the term bell curve, that's what this is. So a bell curve really just talks about the fact that people generally fall in a certain range of values. Most people score average, some people score higher, some people score lower, but typically it's all about a bell curve. That's what this is, okay? Before we start that, we're going to recall a definition called standard deviation. This is something that you have learned before in Algebra 1, but standard deviation is basically how spread out the data is. So this is how spread out data is, okay? It's basically saying how much does any given typical value differ from the mean, okay? How much does anything differ from the typical mean? All right. Two little notations. Standard deviation is given by this, and the way that we say that is sigma. Okay. Now the other one that we're going to talk about is the mean, and remember, you probably know this at least. Mean is the average. So mean is the average, and it's represented by this symbol, and that symbol is mu. So we have two different symbols, sigma and mu, that we're going to be dealing with. Okay? Now normal distribution starts out as a bell curve. That's what this is. Okay? Now basically what that shows is that, let's say that 100 people took a test. The average for the test is right here. Most people are going to score either just above or just below that in that big part of the curve. This part down here at the side and this part down here at the side are the people who scored 100% and the people who probably failed. Obviously there aren't a ton of people that score 100% on tests. There aren't a ton of people that fail tests. That's why those numbers are smaller, but there are a ton of people who score between like 60 and 80, right? So that's really what to think about for that. Now, the way that a normal bell curve is set up looks like this. This is the mean, dead center in the middle. Then we can split this up, and notice how it's a perfect mirror image. So this thing is split up into perfect mirror images. Okay? And now we break this down by saying it's a relationship between mu and the standard deviation. So remember, standard deviation is how spaced out things are. So if things are very close to the mean, that means they're not very spaced out from the mean, right? So mu plus sigma and mu minus sigma are those two. The further apart that we get, the less people are likely to score in this range. So 2 standard deviations away from the mean, notice how the curve is getting smaller. And now even more than that, if we're 3 standard deviations away from the mean, notice how we're way smaller. So we're talking about the area underneath that curve. Now, the way that we look at this, 34% of people typically score just below the mean, 34% of people typically score just above. If we continue on that, 13.5 scored just below that, 13.5 scored just above that, and then now down at this, there's this very, very little 2.35 and 2.35. So it's a perfect mirror image, but notice this makes up 68% of the data, which is typically, pretty accurate, right? This part right here makes up 95% of the data, and this part right here makes up 99.7% of the data. The other 0.3% that we haven't covered, so the 0.3% are when we're talking about these areas here, and those are called outliers. Okay? So those things, anything that is more than 3 standard deviations away from the mean is considered an outlier. Okay, so that might be something that you want to write down. Anything that is more than 3 standard deviations away from the mean is an outlier. Okay, so let's look at, if we look at that curve, or look at that idea, you have that note in front of you, but if we look at this, if I pick a random point P and I say that P is a point between 2 standard deviations away from the mean, and, or I want to figure out, I'm sorry, I want to find the probability that that a point is between 2 standard deviations below the mean and 1 standard deviation above the mean. So that's what I'm looking for. I want to find, if I'm looking at my curve, I want to find something that is 2 standard deviations away to 1 standard deviation away. So this is our mean. And so basically what I'm looking at here is I want to figure out what's 2 standard deviations below is here all the way up to here. That covers 2 standard deviations below. And now what I want to figure out is what about 2 standard deviations above? So if I'm sorry, 1 standard deviation above, and that 1 standard deviation above happens right here. Now all I have to do is look at what my percentages were. It was 34%, 34%, and then 13.5%, and I just add those up. So I just take those things, add them up, and that gives me 81.5%. So the probability that any person was between 2 standard deviations below and 2 standard deviations above looks like that. Okay. Apologies here, this video is going to be a little bit longer because there's a little bit more to type into or talk about, but if we just make up our own random data, so, you know, let's say that a student score, or the average score was 72% for a test, and the standard deviation was 4%, blah, 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 something along these lines. Now what we're going to have to do is we're going to have to construct our very own plot and do the same thing that we just did. We would say that 72% is right here. We would go one more than that, which is 76. One more than that is 80. One more than that is 84, and then anything above 84 would be an outlier. 68%, 64%, then 60%. Anything lower than 60% is going to be an outlier, so on and so forth. I could do this with every single question exactly like I did it right here. But there's actually something really nice that's been created for us. And the thing that's been created for us is actually called standard normal distribution. And what that does is that takes all of the data that we already use and it creates it or converts it to be on a normal table. Okay? Now what that means is with standard normal distribution, they've created a bell curve that has points, and those points look like this. There's 0, 1, 2, 3, and then the exact mirror image, -1, -2, -3. So they look like this, and they are all calculated by something called a z-score. Okay? So the z-score automatically tells us where we're looking on this piece of paper, on that graph right there. And the way that the z-score is calculated is by taking whatever x value you're looking for, subtracting the mean. So they call it, sometimes they call it mu, sometimes they call it x bar. It's the same exact thing, over standard deviation. Okay. Now there's a document on PlanBook that looks like, looks like this, and that document on PlanBook, which looks like this, gives you every single z-score you could possibly want. Now that being said, it also gives you the formula, x minus x bar over standard deviation, and then it tells you really how to calculate this thing. Okay? So we're going to go through a couple calculations so that you can see how this works and so you can see exactly what we're looking at. Alright? So, let's say that we can use any example. An average test score was 73% in a class. 73%. Alright? There was a standard deviation of 8%. Okay? And then it says, what's the probability that any random student scored 84%, or at least 84%. So that's what we're saying. What's the probability that a random student scored at least 84%? So what we're going to do is we're going to convert our z-score. So we've got z equals, now our average is this, so this equals x bar, this equals standard deviation, and this equals x. So now we're just going to literally plug those in. So and since they're all in percentages, we don't have to change them. So we get 84 minus 73 all over 8, which is the same thing as 9 over 8, and 9 over 8 converts to 1.125. Okay, now this is what we want to look for. This is not the probability, this is not the percentage, this is where it's going to fall on my standard normal distribution table. Remember, it looked like this. It was 0 and then 1 and then 2. So we're talking about somewhere in between, or somewhere right around here, and we want to know what the probability is that the student scored at least that much. So we want to know how much of the curve that is right there. So what we're going to do is we're going to go back to our paper. I'm going to look, notice one side of the paper has all negatives, so that's what you're looking at right here. One side has all negatives, and then one side has all positives. So I want to look for the points 1.125, okay? So 1.125, I'm going to copy this over, give me 1 second. So I'm looking for 1.125. 1.1 is right here, and then this column right here means 1.12. Okay, you add those two green things together. 1.1 plus 0.02 is equal to 1.02. So it's really smack dab in between those columns, right? So what I'm going to do is I am going to, there we go, give me 1 second. Okay, so I really want to look at this column here, oops, that column there, and then I want to find the number smack dab in between those two. So I'm looking at the two numbers, 0.8686 and 0.8708, and I'm going to find the average of those two numbers. So I'm going to do 0.8686 plus 0.8708, and I'm going to divide it by 2, and that'll tell me what's directly in between 1.12 and 1.13. So 0.8686 plus 0.8708 divided by 2 is 0.8697, which means there is an 86.97% chance that someone in my class scored at least 84%. Okay? So this is how we can use this data. Now we can use this data with pretty much anything. Alright? There's only a couple things. You have to be told that the question or the problem was normal distribution. You have to be told that you had normal distribution. So in this case, it would have to say the scores were with a normal distribution of blank and blank and blank. As long as you see the word normal distribution, that's fine. If you don't see normal distribution, that's not okay. Alright? So what we have to look at now is there are times when we have something that looks like this that we can't use it. If your data looks like this, that's a perfect bell curve, that means we can use it. If we have something that looks like this, where it starts out and then drops like straight down, that's not perfectly symmetrical, we can't use normal distribution. And then the exact other way is if it looks like this, it's not good, that's no good. This one is called slant left, and this one is called slant right. And we can't use right or left on this. It has to be a perfect bell curve. Okay? So in this one, that would basically mean that my mean is here and my median, my middle number, is there, and notice how the mean is to the left of that. And then the same kind of way, my mean would be here and my median would be here. My mean is to the right of my median. But in this case, both my mean and my median are the same thing, so that means that that's okay for me to use. Okay, so let's go through a couple more examples. Sorry, this video is going to take me a little bit longer because there's a lot to go through. But let's say that this question has a normal distribution. So that thing has a normal distribution, and whatever we're dealing with has a mean of 33, and it has a standard deviation of 4. Okay, mean of 33, standard deviation of 4. I want to find the probability of whatever. Probability of 29. So I'm going to do 33, for my z-score, I'm going to do 33 minus 29 all over 4, because that's my standard deviation, which is the same thing as 4 over 4. 4 over 4 is 1. So now I'm going to go back to my z-score sheet. I'm going to find 1 on my z-score sheet. So when I find 1 on my z-score sheet, I can now just look at 1.0, which is going to be here and here, and notice it's going to be 0.8413. So I've got 0.8413 for my answer. So this is going to give me a probability of 0.8413, or 84.13%. Okay? So that's how that works. So if you want to figure out what happens, or what's the probability that something has, 29-inch arms versus 33-inch arms. Whatever it is, that's what the probability looks like. Now, using the same exact method, and this is going to be a little bit trickier, so bear with me here because this is going to be where we have to start thinking. Okay? All of that stuff is pretty straightforward. Let's use the same exact thought where the mean is 33 and the standard deviation is 4. So mean is 33, standard deviation is 4. But now, let's say that I want to find the probability of 30 to 37. So I want to find the probability that something is between 30 and 37, which basically means I want to find this, right? I want to find what's in the middle here. Now, that being said, everything that I've been finding out has been finding this as well. It's been finding this part as well. I don't want that part. I want that part to go away. So if I want that part to go away, I have to find a way to do this. The way that I'm going to do this is 37 is obviously bigger, right? 37 is here and 30 is here. So if I want to find this, the easiest way for me to do it would be to look at the 37, which the 37 is going to go all the way up to here, right? 37 is going to cover that much. And then if I take away 30, 30 is here. If I take that 30 away, notice how if I subtract these two things, that's going to leave me with exactly what I want to see in the middle right here. That's going to give me my value. So what you need to do here is you need to calculate a z-score for 30 and you need to calculate a z-score for 37 and find the probability of both, then subtract. Don't subtract the z-scores. Find the probability of both of them, then subtract. So find what your z-score sheet says, then subtract them from each other. Okay, so let's try this one. So we've got the probability, and I said 30 to 37. So I'm going to find my z-score for 30. So z equals 30 minus 33 over 4. And then I want to find my z-score for 37. 37 minus 33 over 4. So now when I do this, I'm going to do 30 minus 33. Let me check something real quick. Oops. I typed something, I wrote something in wrong, didn't I? Hang on 1 second. Sorry, folks. I'm just thinking that I maybe did something a little wrong, so I want to calculate or fix it before I go there. X minus X bar. Yeah, I think I did this example wrong right here. So this example, we're going to go back to here for 1 second, and I'm already like 18 minutes into a video and I can't edit it, so I'm not going to change it. But the only thing that's going to change is these two are going to flip spots. So those two things are going to flip spots right there. So it's going to be x, which is 29, minus 33, which is going to be negative 4, which is going to make it negative 1. And now let's look at this where we have to find our negative value. So we want to find the negative values of 1. This is my fault, folks, I'm sorry. And if I look at the negative value here, now I want to find negative 1. And if I look at negative 1, obviously negative 1 is going to be here. So negative 1 is 0.1587. So now if I look at 0.1587, that tells me that this is going to be my z-score, or my answer for this one, not... Wait, why did it... Oh, geez. This is super confusing. This... Oh, okay, so we're good. Okay. So this should be 0.1587. It's so much easier when you guys yell at me during the normal day and tell me that I made a mistake. But anyway, that's what it should look like. So, my fault on the first one. I know you had to go back in your notes, and I definitely apologize for that. I'm sorry. Alright, so anyway, back to this. X minus X bar, X minus X bar, these are both done correctly. So this is going to be the z-score of negative 3 over 4, which is negative 0.75. This one is going to be the z-score of 4 over 4, which is going to be 1. So I've got the z-score of negative 3 over 4, which is negative 0.75, and then 4 over 4, which is 1. So now what I'm going to do is I'm going to go back and I'm going to look at my sheet. I'm looking for negative 0.75. So if I look for negative 0.75, hopefully I can scroll up far enough. I'm not going to be able to. So negative 0.75 is going to be negative 0.75 is going to be here, so negative 0.7. This will be 0, 1, 2, 3, 4, 5, so this is going to be negative 0.75 right there. So my z-score is actually going to be 0.2266. So 0.2266 is what this is going to be, 0.2266. And then when I look at 1, we actually already figured out 1 a second ago. When we figured out 1, we actually found out that that 1 is 0.8413. So that 1 is 0.8413. So when we have this, this is going to be 0.8413. Now I'm going to take the big one, which obviously this is the big one, this is the small one. So I'm going to do the big one minus the small one. So 0.8413 minus 0.2266. And when I do that math, gotta do it quick, 8413 minus 2266 is going to be 0.6147. So that's going to be 61.47%. So that tells me that the percentage is going to be 61.47% that someone was in between 30 and 37. Now, apologies about that crazy mishap in the middle there. That was not my intention. I accidentally switched X and X bar up. If you have to go back on that, if that didn't make any sense, then maybe just skip that example and look at the example that we're staring at right now. If you have questions, ask me about them. I'm also uploading my notes. My notes don't have any mistakes in them, so I'm going to upload my notes. If my notes make more sense, that's great. If they don't make more sense, then don't hesitate to contact me. Okay? Almost done. We've got a couple sections left. Hang in there. You're doing great.